Okay, students, on this very short lesson today, we're going to cover two very simple objectives. First, to define and then to explain ionic bonding based on what you guys have learned on the periodic tables. And these two symbols should not be too confusing to you. They're extracted from the periodic table. Now, if you recall, right, in this symbol over here, the number that is actually smaller represents the number of protons. And for that matter, it will also tell you the number of electrons if this is a neutral as well as electrically neutral atom. So based on what you have learned in Sec 1, right, we realize that in order for me to place these 11 electrons in the electron shelves, you first realize the most inner shelf can only hold 2 electrons. Your second shelf can hold up to 8. And of course, in this case here, after you have 2 and 8, we have 1 left with the last one on the outside. And this, students, is actually the electronic configuration as well as the electron shelves that is for your sodium. Now, just to make sure that this is clear enough for you all. So again, it will be here, okay, 2 shelves here, 8 on your second shelf, and of course, the outermost one with only 1 shelf. Now, when it comes to chlorine, right, we know that we have 17, which means that in order for me to put all these electrons, right, we will have 2 on the inside here, followed by 8, okay. Now, in order for me to explain this more clearly for you guys, right, I think I will prefer to use the electrons in this case here as dots. So after I have 17, okay, minus away 10, I'm left with 7. Okay, now students, in this case here we have the electronic configuration of chlorine as well as the electronic configuration of your sodium. And we all know that in order for them to be stable, right, what happens is they would, okay, want to obtain the octet configuration. Now for sodium, you realize I have 1 electron over here. Now the best way for sodium to actually attain an octet configuration is actually to lose, okay, this electron. And as a result of this, after losing, right, you get something like this. Now in this case here, because the number of protons remains as 11, but now I only have 10 electrons, which means in this case here, I have 1 more protons more than the number of electrons. As a result of this, you will need to put a plus over here. Now, let's consider, okay, I'm just going to put this here. This is your sodium ion. And over here, for my chlorine, in order for me, right, to obtain the octet configuration, the best way, okay, is to actually gain another electron. You will want to ask, where will I then be able to get the electrons? So in this case here, if you realize that what this lose, it has to go somewhere. And in this case here, what happens is that it is actually received, okay, by the chlorine atom. So as you can see, students, the circle dots are electrons that belong to the chlorine originally. Whereas this electron that comes from the sodium will be right here. And now, if you recall, because I have 11 protons and now I have actually, 17 proton, and over here I have now 18. This makes it such that this whole ion would now have a -1 charge, Cl minus. Now, as you can see, I have a positive charge here, I have a negative charge here. As a result of this, right, we have attraction. Now, which means, right, in this case here, because this attraction exists between a positive charge and a negative charge, it is, number one, electrostatic in nature. It is, in fact, an electrostatic attraction. Okay? And you realize that it's electrostatic attraction between these charges which are opposites. And this is therefore it becomes electrostatic attraction between oppositely charged. And what we call that? They are called ions. In time to come, in the next lesson, okay, you will also learn that the positively charged ions are in fact what we call cations, whereas the negatively charged ions are what we call anions. Now, with this in mind, students, in time to come, you will also learn that compounds that are formed by ionic bonding have very high melting point. And that's because this electrostatic attraction are not only attraction, they are actually strong. Electrostatic attraction between oppositely charged, ions. And this, student, is the definition of an ionic bonding. And in using these diagrams, student, you will have effectively also explained to anyone who challenges you what, in fact, is ionic bonding. So with this, I end my lesson. Thank you. Let's stop recording.